We're on. Ha. Okay. Hi, welcome. My name is Chris Heiserman. I'm the president of the Dictionary Hill Open Space Advocates, or DOSA. I want to welcome you to our Geology of Dictionary Hill virtual event. I'm going to say a few words about our group, and then we're going to have a short update from our county ranger for the preserve, and then we'll get on with the program. Dictionary Hill Open Space Advocates is an all-volunteer nonprofit. We challenged proposed development for more than 20 years before we were thrilled when the county bought the hill and adjacent property 3 years ago and preserved nearly 200 acres of special coastal sage scrub habitat to be enjoyed today and for generations to come. Dictionary Hill is a special place in the heart of Spring Valley. It has rare plant and animal species. It's a historically significant site for several types of hill-topping butterflies, and it has splendid 360-degree views from the summit that fortunately are now available for everyone to enjoy. County Parks is still working on a master resource plan and identifying official trails, but the preserve was a great resource, especially this year during the pandemic, where families that were stuck at home could hike and walk their dogs in the open air and natural environment. Now I want to introduce Ranger Craig Newsom for a brief update on the preserve status right now.
Thank you, Chris. Hello, everyone. My name is Craig Newsom. I'm the park ranger for Dictionary Hill, and I've been here for about 2 years. So here's the updates on Dictionary Hill. As Chris said, we're still doing our resource management plan to find out exactly what we have there and exactly where the trails will be. That plan isn't finished, but when it is, it will be brought to the public to discuss and give their opinions on it, and then a final edit before we put it into place. So if you do come out to Dictionary Hill, be aware that the trails aren't super clearly defined. So just try to stay on the most obvious trail, and it's a good idea to have your phone or GPS or something like that with you. The current focus is for me on Dictionary Hill, since as our rainy season comes on, is trail and erosion control and management. We don't have official trails, so we are letting them erode to a certain extent. But for safety, I'll be working on that going forward this rainy season, as well as invasive removal. With the rains coming back, that means plants are growing again. A lot of them we don't want on the hill anymore, like black mustard and wild fennel, and things that choke out our native species that the DOSA works so hard to save. We're trying to keep the natives there and get the non-natives out of there. Other focuses are access control. Prior to the County of San Diego buying Dictionary Hill, it was used lots of off-roading, lots of dump sites, things like that. So we've blocked out all four-wheeled vehicle access, but there's still motorcycles getting in. So that's another of my focuses going forward, trying to get the motorcycles out of there. And since as the rains have begun, growth has begun, and the fire breaks are starting to grow again, as an open space preserve so close to so many homes, it's the county's responsibility to keep 100 feet of clearance from any habitable structure of lots of burning tinder, things that burn quickly. So that's something I want to keep my eye on starting now, and then taking more effect later in the spring. And finally, a big kind of PSA for people who don't know that this is an issue, I guess. The county and in general, wildlife preserves and places have this thing called leave no trace. When you go into nature, we prefer that it looks like you were never there, because that's what the next person wants to see. They don't want to see your candy wrappers or your water bottle or anything like that. You're supposed to take it all out. Unfortunately, there's a new habit that people have been doing of stacking rocks. It can be very picturesque, and it can be like a Zen practice or a workout or any number of things. But unfortunately, in nature areas, it can also be a big negative. The main reasons it's a negative is habitat destruction. Those rocks are hiding places and breeding places for snakes and lizards that we like to have on the hill. And more importantly, for a place like Dictionary Hill, as our expert geologist might be able to tell you about later, we have very shallow soil in lots of places on the hill. So it's really important that we keep that soil so the plants can grow in it. And if the rocks aren't holding the dirt in, then the rain just takes the dirt away. So it's really important to not stack rocks and just leave them, especially if they're in the dirt, leave them in the dirt. If you do stack rocks, please put them back on the ground immediately after. And if you see stacked rocks on Dictionary Hill, feel free to knock them over. Ranger's orders. You won't get in trouble, I promise. So I think that's all I've got off the top of my head. Chris, if you have anything else you think I should say, feel free to hop in.
No, I think that's great. I think those are good points for people to make. Yeah, the motorcycles, I will say that you've done a pretty good job. The access points are really well secure. I think the motorcycles still get in, but they're kind of pernicious, and they're not, there's nothing like it used to be.
Yes.
So it's like
Glad to hear. And if anyone ever sees motorcycles or unauthorized vehicles in the park, please contact me. My work cell is 619-323-6075. And my work email is craig.newson, Newson, @sdcounty.ca.gov. You can also just let me know if you like things, don't like things in the park, anything, feel free to reach out. That's it for me on this. So thank you, everybody. Thanks to DOSA. They do incredible work. Organizations like that are why we have this park in the first place. And I encourage everyone to find a community organization like this and try to give back, because it really is incredible the work they've done. So thank you guys, and thank everybody watching. Come out to the hill, go for a hike.
Thanks, Craig. And so now we're going to get on for our unique presentation on the geology of Dictionary Hill. We're going to have our moderator is going to be Ken Barrett, who's the DOSA newsletter editor and videographer. He's done quite a few nice videos that you can see on YouTube of the hill and the birds, and some of it set to really nice music. And then our local geology expert presenting will be Jen Morton. And so I'm going to let Ken take it away and introduce the program. Thanks, Ken.
Okay, thanks, Chris. Tonight, we're very fortunate to have Jen Morton with us. First, I should apologize for the light on this shot. I've had a problem with the light in my room here. It's not showing at the books as it should. But we're lucky to have Jen with us this evening. Jen is a local geologist. She's UCSD trained. She's the owner of Terramar Environmental Consulting. She's a past president of San Diego Association of Geologists, and she's taught geology and oceanography at Palomar College. And currently, this is interesting, she's working on a compilation of geology hikes in San Diego County, something to look out for. And she spent a lot of this pandemic, she tells me, hiking or escaping from people, hiking over the hills in search of geology. Now, I should say that when I climb Dictionary Hill, I stand at the top, I look at the view, but I don't think of how did this hill get here? What kind of rocks am I standing on? How old is this hill? How has it been eroded? I just stand and look at the view. So tonight, Jen will explain to me and the rest of us exactly what is under our feet when we stand on Dictionary Hill. So Jen the geologist, or Geology Jen, off you go.
All right, thanks so much, Ken. I'm so happy to be here with all of you tonight, and really excited to share about the geology of Dictionary Hill. As Chris said, Dictionary Hill is a very special place, and I just want to applaud everyone who was involved with saving it and saving it from development, and so that it can be an open space for everyone to enjoy for years to come. So I'm going to go ahead and share my screen and my PowerPoint that I put together.
Jen, can I just interrupt you a second? I should have said that if anybody watching wants to ask you a question, you go to the bottom of your screen to the chat function and just type in the question, and Jen will try to deal with it later. Okay, off you go, Jen. I'm sorry.
All right, no problem. Thanks, Ken. So I'll do my best to answer any questions that might come up. So to start with, Dictionary Hill is, I think it's really special from a geological standpoint because it is a remnant of a volcanic arc. And in San Diego County, we have a few different hills that are considered remnants of what we call the Santiago Peak volcanics. These are 120 million year old volcanic rocks. And so when I talk about a volcanic arc, I'm going to give you a few examples of what some modern day volcanic arcs are. So Japan, Indonesia, and the Aleutian Islands are somewhat similar to the Santiago Peak volcanics, at least in the way that they were formed. Now, these volcanic arcs that we see today, a lot of them will occur around the Ring of Fire. So some of you may be familiar with the Ring of Fire. It's basically a ring around the edge of the Pacific Ocean where we have a lot of volcanoes and a lot of big earthquakes. The largest earthquakes that we tend to have on Earth typically occur on the Ring of Fire, and the reason for this is that they are a number of convergent plate boundaries around the Pacific Ocean, and this is where subduction occurs. So subduction is when one tectonic plate dives beneath another tectonic plate. And so we have oceanic crust, in this case, diving beneath another slab of oceanic crust. And when this crust dives deep into the earth, there's a depth at which it begins to melt. It turns to magma, and that magma will rise up and form a volcano eventually. And molten rock is one of the three classifications of rocks is igneous rocks, and those are rocks that form from a melt, something that has melted or has been molten in the past and then solidified. And so another feature, so the Santiago Peak volcanics are the volcanic extrusive version or part of this past convergent zone that was present on the west coast of the United States and formed the Santiago Peak volcanics. So there's also an underground portion of this convergent plate boundary. So in this type of environment, we're going to have extrusive rocks and intrusive rocks. And underground, we can have a large magma chamber. Well, if anybody's ever heard of the Peninsula Ranges batholith, I'm going to talk some more about that. But it's a very, very large magma chamber, and we call those plutons. So the rocks that form within this large magma chamber are considered plutonic rocks, and the Peninsula Ranges batholith is associated with this former convergent plate boundary. Now this subduction stopped many millions of years ago in this area. It's still ongoing in other parts of the Ring of Fire, but here it's no longer happening. So no active volcanoes currently associated with this. But when it was occurring, we had a large, vast amount of magma that formed underground and a large amount of volcanism that occurred at the surface. So some examples of what we consider extrusive rocks or volcanic rocks that formed on the surface are rhyolite, andesite, and tuff. And intrusive rocks include granite and gabbro. And the difference between the granite and gabbro has to do with its chemistry. But what we typically see in the differences between the extrusive rocks and the intrusive rocks is a difference in texture, in the size of the crystals that form within the rocks. And so extrusive rocks cool very quickly at the surface, and they tend to form a smooth, fine-grained texture where it's usually you can't see the individual crystals. Intrusive rocks have a lot more time to cool underground. They cool very slowly, and that allows the molecules in the crystals to form these nice crystal structures and grow into larger crystals that can be seen with the naked eye in the rock. Within this system, this former convergent system and the Peninsula Ranges batholith, the batholith formed between 105 and 140 million years ago. But we tend to consider that the Santiago Peak volcanics are slightly older than what we see in the batholith in this region. And then there's an eastern and western batholith. The eastern batholith is actually a little bit younger. We see some gabbro forming in more gabbro in the western portion, closer to Dictionary Hill, closer to the Santiago Peak volcanics, and the rocks become more granitic as we go a little bit further east. So again, the Santiago Peak volcanics are 120 million year old volcanic rocks. And as I said, this is one of the few places in the county where these old volcanoes still exist. And so as a geologist, I get really excited about things that are kind of unusual geology, things that we don't see everywhere. And so that's part of what makes Dictionary Hill a really special place. And so these are some photos that I took on Dictionary Hill of the volcanic breccia that we tend to see. So over the time frame that these rocks existed, the Santiago Peak volcanics are dated between 110 and 128 million years ago. And so during those millions of years, there were numerous volcanic events. And what we see is some alteration of some of the rocks through subsequent volcanism. So we would have, one lava flow occur, and then later on, maybe an explosive volcano, some explosive volcanics happened, and it would have altered the pre-existing rocks. So volcanic eruptions, there can be different types of volcanic eruptions. You can have lava flows, pyroclastic flows, we can have explosive eruptions, and it sort of depends on the type of volcano and where they're located and what's causing the volcanism. But we seem to see some examples of all different types of volcanism on Dictionary Hill and in the Santiago Peak volcanics that are in this area. When we have explosive eruptions, we have a lot of gas and dust and debris that forms, and then that will congeal or solidify into a type of rock called tuff. So we talked about igneous rocks, rocks that form from a melt, and the other two classifications of rocks are metamorphic. And metamorphic rocks are rocks that have been altered. There was some initial, maybe it was an igneous rock, maybe it was sedimentary, but it was subjected to some change in pressure and temperature, and was transformed into a different rock. So meta means change, and serpentinite is an example of a metamorphic rock, and it also happens to be the state rock of California. And then the last classification would be sedimentary rocks. And so a couple of examples of that are shale, which is a fine-grained sedimentary rock formed from like muds, fine-grained material, and sandstone. And so the sedimentary rocks are formed from other rocks eroding, breaking down and eroding, and then becoming cemented. The particles become cemented together to form a sedimentary rock. And so in San Diego County, our county is really dominated by these rocks of the Peninsular Ranges batholith. And now I had mentioned that these rocks form deep underground in these vast magma chambers, but over millions of years, they've been uplifted and uncovered. And now we see them at the surface. So when you drive out east and you see big bouldery outcrops, those are part of what were formed underground and part of the Peninsular Ranges batholith. So this is the Western batholith and the Eastern batholith. And this green stripe down close to the coast is where we find the Santiago Peak volcanics. So not a whole lot remains from these old volcanoes, but we do see a strip that goes down along parallels the coast, and then the coastal areas of San Diego are really dominated by sediments, and those were all derived from the former mountains and flowed down towards the ocean. Okay, so this is a more detailed, that was a very simplified map, but this is a little bit more of a detailed map of the igneous rocks in this region. And so we see in red the batholithic rocks, and then here in the little green outcrops are the Santiago Peak volcanics. And so you can see that there's just these little bits in different locations throughout the county. So some other areas that you might be familiar with where we see the Santiago Peak volcanics are Mount San Miguel, Iron Mountain, Black Mountain, around Lake Hodges, and in the Rancho La Costa Reserve. And then they continue on up into Orange County in the Santa Ana Mountains. So what do we see on Dictionary Hill? What kind of rocks do we see here? Here's a geologic map of the El Cajon quadrangle. And on this map, we see here's Dictionary Hill. Here's about the top of the hill. KSP is the designation for the Santiago Peak volcanics on this map. And that is described as unmetamorphosed to slightly metamorphosed volcaniclastic, and hypabyssal rocks, dacite and andesitic breccia, tuff, and flows. And then there's some basaltic and rhyolitic compositions in some areas. We may not necessarily see all of those in each location, but that's the general description of the Santiago Peak volcanics. And then we also, as some of you may know, that we also have Cuyamaca Gabbro, which outcrops. You can see an outcrop of it at the end of Barcelona Street, and just to the northeast of Dictionary Hill. And so this is where the Cuyamaca Gabbro is, and that's part of those batholithic rocks that were formed underground. Okay, so on Dictionary Hill, we can see volcanic breccia, and the breccia is really a sort of like just a mess of different types of rocks. And so we'll see within the breccia some of the old volcanic rocks. You can see these are kind of shiny, and they're smooth textured, very, very fine grained rocks. These are probably parts or pieces of an old lava flow. And then surrounding it, we see more of a tough, tuffaceous type of texture. So this was probably more of that tough type of volcanic rock that forms from the dust and explosive or pyroclastic flows. And when you can't really see it so well in these photos here, but if you look up close to a lot of these outcrops, and this is really the places that I've been on Dictionary Hill, this is primarily what I've seen is this volcanic breccia, and you'll see these little shards or little bits of broken up rock within the fabric of the outcrop. And so what we think is that these are probably there was some volcanic rock that was there initially, and then subsequent eruptions disrupted it, blew it apart, and then it all sort of came back together and solidified into this breccia. So to me, this is a really, really interesting type of rock because there's just so much. I mean, it just looks very chaotic, and there's just so much going on, and so many different interesting things within each of the outcrops. So now one of the things that people refer to these rocks as is the metavolcanics. And the term metavolcanics means that some of these rocks, actually most of the rocks on Dictionary Hill, have some sort of change, some sort of alteration to it. And this was probably an andesite originally. There's an outcrop. This was taken on the like the south side of the hill, towards the top of the hill, and you can see that it's got sort of this greenish hue to it, and that's probably chlorite. It's hard to say for certain without taking it to the lab and looking under a microscope exactly what the composition is, but likely these have been altered with some sort of chlorite or possibly epidote. So these were volcanic rocks, maybe of andesitic composition, that were altered due to the volcanism. So they weren't altered enough to completely change and become new rock types. So they're not metamorphic, but they've been altered enough that they're a little bit different from the original rock that had erupted and solidified. And then tuff. I found this very interesting. There's a big outcrop on Apple Street, on the, I think it's sort of like the north side of Apple Street. There's a big outcrop just on the side of the road, and it's this very light colored rock, and that's tuff. And I saw some on the trails as well. And sort of a light colored rock. Some of it's very crumbly. It's not very it's most of the Santiago Peak volcanics are very, very solid rocks. They're very they're very resistant, but there's some of this tuff is very erodible, very crumbly, I noticed. And then lastly, we've got gabbro, and there's just really, I don't think I haven't seen anywhere I've been on Dictionary Hill going up the hill, but right at the end of Barcelona Street on one of the trails, as you're going in, there's an outcrop of gabbro, which again is one of the rocks that formed within the batholith. It's one that it's more of an iron rich rock, whereas a lot of the Santiago Peak volcanics are more, they have more of a silica content to them. And then just to finish up, I've got a few overview shots from the top of the hill. It's so beautiful up there. I actually went back up yesterday and took some more photos, and it was just, oh, sorry, I just went a little too far. It was just stunning being up there after the snow, after having all the snow in the mountains. You could see the Cuyamaca Mountains. And this, let's see, I don't think I ended up having a photo here, but you can see, as most of you know, the Coronado Islands from here, which were formed. They're really formed from a lot of sediment, and the thought is that the sediment came from a landmass that was further west. That's no longer. It's been completely eroded and is no longer present. Which I think is really interesting. And then it's probably a little hard to see, but off in the distance, we can see, here's, I think, downtown San Diego, and then Point Loma, and Rose, I'm sorry, the Mount Soledad, which those high points are formed they've been uplifted along faults, the Rose Canyon and faults of the Rose Canyon fault system, and more of a sedimentary environment. And I've got a picture of Mount Miguel. Sorry about that. And Mount Helix. And then I believe this is Black Mountain in the background as well. So I'm open to any questions you might have. I'll do my best to answer them. And I guess I'll turn it back over to Ken now for any questions.
Okay, thanks so much, Jen. That is just fabulous. There's one question, a very juvenile question, that the houses around Dictionary Hill, especially on the south side on Buena Vista, those steep roads, they're built on the side of a volcano. Do those people need to worry that there's going to be an eruption?
No,
they need to increase their insurance.
That's a good question, but there's no need to worry at all. The volcanoes are long since extinct, millions of years, and so there's no longer any subduction occurring. Around 60 million years ago, is when the San Andreas Fault formed, and I believe it was around that time that the subduction, or before that the subduction had stopped, and then the movement, the way that the plates move relative to each other, the North American and the Pacific plate move, completely changed. So there's no longer any subduction, so no mechanism to cause the melting any longer. So yeah, so we're all safe from any volcanism.
Right, that's a relief. And I just wondered, next time I climb the hill, maybe after the next rain on Friday, is there any particular piece of rock, type of rock, I should look for, and what clues can I see in it, the crystals or anything I should really keep my eye open for? Not that we would take any souvenirs, of course, but
Well, when I went this yesterday, previously I had gone from the Barcelona side and did the long hike up, and yesterday I went from Buena Vista Street, and right when you get on the trail and you look to the right, there's this beautiful outcrop of breccia. And it's just so cool. It's a big outcrop, and if you go and you look at it, you can see all these different textures in it. And if you look up close, you can see the little angular rock fragments within the texture of the rock. And then you should be able to see some of the smoother rocks that are within that that sort of tuffaceous material. And so just to me, it's very interesting to see all these different types of rocks all that have all sort of been congealed together in this breccia.
Okay, and I'm looking on the screen here. There's a question: are plutons solidified magma chambers?
So the Pluton, it is, well, when we talk about so a Pluton is a very, very large magma chamber, and eventually it will cool. And then when we refer to the peninsular ranges batholith currently now, we're typically talking about the rocks that have cooled and are exposed at the surface, but they were underground in a magma chamber, when they before they cooled.
Okay, and one of my questions from when I was in high school, I did a geomorphology course, learning about landforms, glaciation, and river erosion, and so on. And I look at Dictionary Hill and think, this is dense, hard rock. How did it get worn? Because we have so little rainfall, and yet it's been eroded into this low dome. I think of
Right.
Mount Fuji you showed us, and then we've got Dictionary Hill. So what
Yeah.
were the agents of erosion in the last 110 million years, whatever it is?
Right. And so I think that it's because it's been so many millions of years, it's had a lot of time to break down. It's had a lot of time to be exposed to the elements. There have been periods of time, in the past where we have had a warmer, wetter climate in San Diego, and I think it's just had enough time to wear down. And imagine that these mountains there were more of them, and they were much bigger than they are now. But yeah, they've been able to erode, even though it is very resistant rock, these volcanics. But yeah, it's just been, we don't have any glaciation in this area. It never, the glaciers never made it far, as far south as San Diego, so we know that didn't have any effect on it. But we do have just the cold and warm, going back and forth between cold and warm weather, and water, and yeah, just the typical erosion
So
as far as I know.
when we look at, for instance, Yosemite, that's carved out by glaciers,
Yes,
whereas
there was.
we're so far south, we that never reached us.
That never reached us, yeah. And the some of the volcanic arcs that I showed initially, those are much younger. So that's still in Japan. Subduction is ongoing and active, and in the Aleutian Islands, it's all still forming. It's the subduction still happening, and
Right.
although it's over a very long, geologic time frame. So
So here we are. Janet Terry asks us, please rate the top 3 geological sites on Dictionary Hill. Oh, yeah.
hmm. I haven't spent a lot of time. I've only been on a couple of hikes to Dictionary Hill, but like I said, we're coming up on Buena Vista Street or Buena Vista Avenue. That outcrop right when you come up, that's really interesting. As you go to the top of the hill, there's more. You can see more outcrops of this volcanic breccia as well. Yeah, I just think that there's some really. It's more on probably on the south side of the hill that I saw these great outcrops. But I need to do more exploring up there. And in fact, the one of the Dictionary Hill hike is going to be one of the hikes that's going to be featured in our SDAG hiking book as well. So we need to do a little more exploring and see if there's more to see.
Okay, I've got a question here on my screen from Steve Babbitt. We've all experienced that the rock is just a few inches below the topsoil. About how deep does that rock go?
Well, the rock, I mean, it's going to go all the way. I mean, it's hard to say. Like it's basically bedrock. So that's like the volcanic rock is the pre-existing rock under the surface. So it's going to go down to, it's probably where the crust ends. So.
Yeah, and then I got one. This is a question maybe more for Chris, if you can hear us, Chris. Is what area, this is from Justin, what area is considered Dictionary Hill?
Yeah, I think we also heard that your screen share is still on, Jen, so
Oh,
maybe
I'm so
if you,
sorry.
that's
Thank
okay. I
you.
just might make it a little different.
Yeah.
Okay. Yeah, what area is considered, the actual hill itself, the preserve is almost 200 acres. It includes the top of the hill. The preserve boundary basically comes down to almost South Barcelona, down the canyon from the hill. So the preserve is more than just the top of the hill. It's the hill and the canyons adjacent to it. And then, but at South Barcelona, approximately, there's also a county trail easement that's not technically part of the preserve, but it's a county trail easement that goes down the canyon, and it's in open space that's also preserved, as a conservation easement over it. So it's adjacent to it and extends the trail, a county trail easement down the canyon all the way down to Highlands Ranch and Point Parkway. And so the hiking trails are more than just a preserve, but they're adjacent and that kind of thing. I think somebody also asked a question about parking. And I think we eventually will have official trails. But a lot of people are parking at the end of South Barcelona, where they can actually access the county trail easement and also go up to the top of the hill from there. And another pretty good access where there's parking is, although you have the steep hills on the south side of Dictionary Hill, there's a gate for the Otay Maintenance Road for their water tank that comes at the end of Buena Vista, pretty far up the hill, but there's a gate there and there's on-street parking that the neighbors are kind of used to seeing. So because people are hiking in there. So those are probably the most popular areas.
Okay, the question from Howard, is Otay Mountain part of the Santiago Peak Volcanics? Do you know, Jen?
I believe it is. I believe it is. I
So
don't know for certain, but I'm almost positive that it is.
Yeah. And I'm thinking of the Gabbro you talked about at the end of South Barcelona.
Mhm.
That's up on the left. There's some huge boulders, worn rounded, and there's a nice cactus garden there that somebody's established there. So they're the Gabbro rocks. You just go to the left at the end of South Barcelona.
Right.
Yeah.
That's right.
They're impressive. So if anybody wants to see Gabbro, go to the end of South Barcelona and make a left, and it's up a slight rise, and you see these immense boulders, and it's a good viewpoint as well. Good viewpoint. Right. So I want to ask you, if you can, Jen, you haven't mentioned Cowles Mountain, where 10,000 people a day climb Cowles Mountain. Is that part of this system?
I believe that is as well. I had that written down yesterday, and I believe that Cowles Mountain is also part of the Santiago Peak Volcanics.
Yeah. One last question I have: if I take my magnifying glass up the hill and I get one of the stones in my hand, what do you think I'll be able to see with a lens of the magnifying glass?
Well, again, like the Santiago, the volcanics are going to be a fine grained. So you won't probably be able to see any individual crystals in any of the in the volcanic breccia or any of the flows. But what you might see are fragments of other rocks within a rock that you pick up, and so that's pretty interesting. And let's see, in the Gabbro, I believe that when I looked at the Gabbro, it was there's a lot of variation in Gabbros, and I'm trying to remember what we saw in that Gabbro, but you might be able to see some individual crystals in the Gabbro of I'm not sure offhand.
Okay.
So,
and then one question from Janet is, why is the top of Dictionary Hill flat? I think if this is an extinct volcano, was this the crater?
that is a good question. Now, I understand that the history of Dictionary Hill, there was a period of time when it was used as a lookout, And it is surprisingly flat up there. I'm wondering, is it possible that it was graded at one time, the very top? Um,
So
because
Chris,
it,
do
it
you
is
know?
very flat.
Well, our resident biologist, Jim Mertzbacher, would know, but I don't think he's on, he's on the call. Basically, I think from his standpoint, it's one of the reasons that it's such a historically significant site for butterflies is because it's so flat and open and the shape that it is. And notice that there's no like forest there, trees or things like that. That's part of the soils and the rocks as well. But I don't think it per se has been graded, but I mean, there's the off-road activity and things like that, but I don't think it was ever really intended to actually be graded. Although the people that wanted to develop it were going to blast off 30 feet and then put houses on it. So I'm glad that didn't happen.
Yeah.
Right. Well, I just have one last question that's occurred to me. Jen, you talk about it was volcanic eruptions here from the subduction of the Pacific plate. Did those eruptions happen? Was there a long gap between each eruption, so several years or centuries maybe, or did it happen in quick succession?
It's hard to say, but I think it's very possible that there were long gaps in between. I think that that's very definitely possible. Yeah.
Right. So I want to thank you. That's super. Now I know if I go up there tomorrow, nice bright, no, maybe after the rain on Saturday or Sunday after the next rain, when the views are good, then I'll be able to look down at my feet and think, I know something about the geology of this, and that's thanks to Geology Jen. So thanks so much for giving up the time in your evening. That was
You're
wonderful.
welcome. You're welcome.
Okay, back to you, Chris.
Well, I think we pretty much covered it. If there's no more questions, want to thank everybody for joining us. I believe it's been recorded and it will be available also on the YouTube site where we have other videos. And so I guess we want to thank all the people involved. Thank Jen, thank Ken, thank our technical person Dustin, and Ranger Craig, who was with us for a while. And we appreciate you tuning in and hope to see you on Dictionary Hill and in future virtual events. So thanks a lot. We appreciate it.